We are Lash Plus International. So today we're going to speak about something that's getting a lot of attention, which is LED lash extensions. Have you guys concerned about the safety of LED lash extensions? Yes? Have you guys doubted about the power of LED lash extensions? Yes? So, LED lash extensions, so I had that same, I doubted about LED lashes and, I was kind of scared before, but LED lash extensions are taking whole world by storm, particularly in Asia. As I have been teaching, educating hundreds of students so far for the past few years, I can see it's becoming new normal. My name is Kiki. I do help and support people in becoming true lash professionals. My lash extension journey started about 15 years ago with no English and little money when I arrived from Japan. Lash extension became my sole passion, which leading me to become eyelash champion in a number of global lash competitions. With the support of my partner Andrew here, we are now running 4 successful eyelash extension salons in Sydney, as well as worldwide lash supplies. So LED lash extensions are simply great for lash artists and clients. This is because it offers the best retentions. Also, we can offer this service to your client as a premium service. From my experience, even though we charge an additional cost of $30 on top of the normal service, our client would never want to return the conventional lashes. This is because they love the retention. Also, they feel more comfortable to wear because there will be no fume. So what's the main difference compared to conventional lashes? What makes them so special? So this is the LED glue that we use. It contains special ingredient, which is called photoinitiator, as you can see here. So this is a crucial component in the LED lash extensions. It's a substance in the adhesive used to attach LED lash extension to initiate the bonding process when exposed to UV light or visible light. But are they really safe? As you can see here, gel nail lamp has been in the media due to the potential risks of UV exposure. So gel nail lamp is extremely powerful compared to LED lash extension light. Because of this association, many people think the LED lash extension can be quite harsh. This really depending on the intensity of the light output. So I'm going to swap to Andy here to explain about UV radiations.
Hello everyone, my name's Andy, as Kiki mentioned, and we both live on the Gold Coast, and being on the Gold Coast, I guess you could say we know something about UV. I get a suntan just by walking my dog, and but I'm here today because on our 3-year journey developing our product, we've been listening to the community, researching, reading blogs and articles around this concept of UV applied eyelashes. And today, I want to take you through 3 myths that I hope to bust. So these are 3 questions, and I hope we can all kind of be a bit interactive here. And the first thing that we heard, and the first one I'll address, is that we hear that because it's an LED, it's not UV. So I guess maybe if we could just have a show of hands, don't be shy. If you think it's LED, is it not UV? Okay, so pretty much unanimous, no hands there. So I'll move to the next question. That is UV invisible? So can we see UV light? Maybe just a show of hands, does anyone think that UV light is invisible? Okay, okay, starting to see a few more hands here now. Yeah, great, thank you. And then the final one, probably the easiest one for us as a crowd, UV is harmful. Now, clearly, it's got to be harmful, right? So just a show of hands who thinks that UV light is harmful. Okay, great, definitely more people here. So I'm going to go through these kind of questions and commentaries that we've heard quite commonly amongst the community. So let's tackle the first one. LED is not UV. So this is something we've been reading quite a lot and had a few questions about, and I think there's a bit of a misconception about LED and UV because LED is, as I'm sure you know, a light-emitting diode. So what is a diode? A diode is effectively a light bulb. So it's something that emits a low-energy light, and those LEDs can produce red lights, green lights, blue lights, yellow lights, all sorts of lights. And in fact, those old school TV remote controls that we used to have, LEDs were used to emit infrared light to change our TV channel. But LEDs can also emit UV light. So it's just a spectrum of light that absolutely LEDs can emit. So the question was a bit of a trick question. It probably should be, can LED produce UV? And the answer to that is, yes, it can. So the next question is UV light invisible? And again, sorry, there's a few kind of trick questions. I guess this is where the myths kind of come in and the busting them. So the reality is that UV sits in a very interesting part of the light spectrum. And for those of you that have done kind of some research in this space, you'll know that light is measured in what we call nanometers. So that's just, you measure a length by a centimeter, light is measured by nanometers. And UV light sits between 200 and 400 nanometers. That's the range it sits in. And it goes from UVA, UVB, and UVC. Now, the human eye can actually detect from 380 up to 700 nanometers. That's our visual range, and that's the colors of the rainbow. And I guess for those that are paying attention, you'll recognize there's a bit of an overlap of 20 nanometers. From that 380 to 400 is where we can actually see UV light. Certain animals can actually see more of the spectrum, incidentally, but it's just literally just our eyes. It really is not too relevant in terms of whether it's visible or invisible, but it's interesting that it kind of sits within this interesting range. And what's particularly interesting is that we see some products coming to market that say, oh, we're in this 410 nanometer range, so we don't sit inside UV light at all. We're in this, we're safe. And the reality is that all of this light spectrum, and really is what the key catalyst to initiating those photo initiators that Kiki mentioned, is what we call high energy visible light. And it's this high energy visible light that can penetrate into the glue and actually starts this bonding and curing effect of the glue. So hopefully that's cleared that one up. So the next one is UV light is harmful. So is UV light harmful? I'm just going to hand over to Kiki to talk about this section, and then I'll get into some data about this too.
As Andy mentioned earlier before, there is different kind of light, including visible light and invisible light and high energy visible light. There is two types of UV, so UVA and UVB are the type of light that can reach to our skin. For example, when you get too much sun for a long time, your skin can get darker, which causes collagen destruction. It can make your skin uneven and sagging, which is because of this UVA. The UVB is causing inflammation or soreness, or like sunburn, which can create spots or freckles later on. This is because of the UVB. And HEV, also blue light, can also penetrate to the skin or eyes more deeper, which is why our eye gets really tired after you playing on the phone for a long time. And we're going to be sharing some interesting data about UV radiation from Andy.
Yeah, thank you, Kiki. Yeah, absolutely. So, as we mentioned, blue light is becoming something quite well known in the media because it affects our sleep, our circadian rhythm. So that's pretty interesting. And also, this is one of the main light sources that sunglasses try to block as well, incidentally. But what we decided to do was we decided during our research and development of our particular product, we wanted to test some different sources of UV, so either natural sources of UV light, as well as some of the products that we started to see enter the marketplace. So what we used was this digital light meter. This actually detects the amount of UVA and UVB light that's being produced from a particular source. And these were the results that I'll just show at a high level. So the first one that we see here is we measured the sun on the Gold Coast at 1:30 in the afternoon on the 16th of January. And we got a reading of 7,800 microwatts of UV iridescence that was being produced. And on that same day, in a controlled environment, we tested a nail lamp for its UV iridescence. And as you can see, it was producing 9,500 microwatts of UV iridescence. So you probably sat there thinking to yourself, there is no way that a nail lamp is producing more UV than the sun, right? I mean, the sun is a pretty powerful source of energy. Well, you have to take into the context of there's an atmosphere, there's an ozone layer. It was a clear day, incidentally. It was a beautiful day on the Gold Coast on the day that the reading was taken, but there's particles in the atmosphere. So then there's obviously a greater distance for that light to travel as well. Whereas the actual nail gel device was, the sensor was placed approximately where your hand would be placed. So we weren't trying to hold the sensor too closely to the light, but it's uninterrupted light source, as you would imagine, and very high power. I think the light itself was 74 watts of power that particular device was producing. So quite surprising. But then what we also wanted to test was we wanted to test these devices are becoming quite popular in the market, and there are a lot of people that are kind of white labeling and reselling these LED gooseneck lamps. And we wanted to test these devices for their level of safety. And with this particular device here, again, in a controlled environment, we tested it's producing around 1,500 microwatts of UV iridescence or UV radiation from this particular light. On that same day, we tested our solution, the Laser Lash Pro solution, and it was producing 15 microwatts of UV iridescence, so 1,000 times less UV iridescence than the floor lamp just here. But let's put this into some kind of context here. Let's go back to one of our original examples here, the sun. So as I mentioned, we were producing 7,800 microwatts of UV iridescence that was being produced from the sun, and 15 microwatts from the Laser Lash Pro system. But what does this mean? I think one of the biggest misconceptions that I see in the industry is firstly around this concept of the nanometers. If it's a certain nanometer, it's safe. If it isn't safe. I think what the industry is really failing to overlook is an important concept of exposure dosage. You will understand if you go to the beach and you lie on the beach for 1 hour, then you're probably going to start to feel the effects of the sun. However, if you step outside and walk in the park for 5 minutes, the effects are far less. And that's because UV is an accumulative process. So we reverse engineered the numbers that we presented during this presentation. And on the Gold Coast on the 16th of January at 1:30 in the afternoon, you'd approximately have to be outside for 7 seconds to be exposed to 546 joules per square meter of UV iridescence. And the equivalent of using our product would be, which is quite precise, you'd have to be holding that light on your skin for 60 minutes directly in one location to get 7 seconds worth of the same level of UV exposure. So, I mean, I'm sure when you're going to the beach, you're not necessarily like rubbing sun cream into your eyelids, but another important thing that you ought to consider is around the heat and the intensity of light. So, but like that's all kind of bunch of numbers, you know, it's, you know, a bit of science in there, but like ultimately it comes down to seeing is believing. So at this point, I'll just ask if we could just dim the light slightly, please, because we just want to show you what the effects of what UV is. So first off, I'll take our Laser Lash Pro product here. And what we're going to see here is we are, oh, is this connected? Oh, sorry, I just need to switch this on, sorry. Taking our Laser Lash Pro product, we've applied some UV activated paint to this particular board here. Sorry for those at the speaker table, probably are not able to necessarily see this, but you'll see the light is actually producing an effect. It's radiated. So we're not claiming that we're not producing UV. You know, it's an important part of the solution, as we mentioned. It's actually a catalyst that starts the whole bonding process. However, when we compare this to a gooseneck lamp, whether you can press that, honey, I can take over. You can see the difference here in terms of the power that this is producing and the effect on this UV activated paint. So, I mean, the first thing I would say is, first of all, if people are telling you that their device is not producing UV, just try it against some UV activated material. You will see that. Another thing I would suggest is, you know, feel the heat of this device on your skin and imagine that shining in your eye. And then, you know, even like do the eye test. I mean, it's literally quite blinding, even with your eyes closed. So, yeah, that's really the end of the data, and I'll just hand back over to Kiki to close off. Go back to the presentation, please, guys. Okay, it's fine. Let's go to the last one.
The Laser Lash Pro has been designed specifically with the safety in mind. It provides the best retention, allowing your client to take shower or have a swim straight after the appointment. And also, it's a minimum output of the light, so it's very safe to your client, also a lash artist. And if you want to try this out, we have a booth outside, and yes, we're happy to help you through about applications. Thank you very much.
Thank you so much. What an interesting topic, and as we said, so relevant now. Thanks so much, guys. We would love